Hi everyone, welcome back. Yesterday we talked about inscribed polygons. Today we are going to learn about properties of tangent lines so that we can talk about circumscribed polygons tomorrow. So inscribed polygons, remember, are polygons inside of a circle. Circumscribed polygons are polygons outside of the circle. So I'll show you that tomorrow, but first you need to learn about tangents. So here's a theorem that you should know. In a plane, a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. Now this point of tangency shown in the picture here is point A. This is the only point that line L touches circle B. The tangent line only touches the circle at one single point, called the point of tangency. Now since this theorem uses if and only if, it can be read both directions. So we could say L is tangent to circle B, then you could conclude that segment AB is perpendicular to line L. Or you could read it the other way around. If you know segment AB is perpendicular to line L, you could conclude that line L is tangent to circle B. Let me show you how to use this in an example. So let's say we wanted to identify tangent lines. It says segment JL is a radius of circle J. Determine whether segment KL is tangent to circle J and justify your answer. So if segment KL is perpendicular to the circle, then angle L should be a right angle. How can we test if this is a right angle? We could check Pythagorean theorem. So what we're going to do is we're going to do 8 squared plus 15 squared and see, is that equal to 9 plus 8 squared? Notice that 9 is on the outside this segment. 8 would be the rest of this segment since it's another radius. So altogether, segment KJ has a length of 17. So if you wanted, you could just put 17 squared. So now let's check this. 8 squared is 64. 15 squared is 225. And we want to know, is the sum of that equal to 17 squared, which is 289? Is 225 plus 64 equal to 289? Yes, it is. So we have 289 equals 289. That's a true statement. Therefore, angle L is a right angle. So we can say yes, segment KL is tangent to circle J because it is perpendicular to the radius. JL. All right, I want you to try the one shown to the right. It's very similar. Here's the correct answer. Notice on this one, I think I should have drawn this for you, but HF is 12. I'm sorry, it kind of looks a little confusing there. Next, let's do another example. This one, we are given that it is tangent to circle G at point J. We want to find the value of x. So since we know that JH is tangent, we know that it makes a right angle with the radius. So if we're trying to find the value of x, we can do x squared plus 12 squared equals, we can write this as x plus 8 squared. Now in order to solve this, the first step, we can square 12 to give us 144. Now, if we want to square x plus 8, the whole quantity, you have to multiply it by itself. So we have to distribute this. X times x is x squared. X times 8 is 8x. 8 times x is again 8x. And 8 times 8 is 64. Let's combine our like terms on the right side. 8x plus 8x gives us 16x. Now notice that the have x squared on both sides of the equation. If we subtract x squared on both sides of the equation, it will disappear. It will give us 0 on both sides. So we just have 144 equals 16x plus 64. So how can we solve this? We can subtract 64 on both sides to give us 80 equals 16x, and then divide both sides by 16 to get x equals 5. All right, I want you to try the practice problem given to the right. Here's the correct answer. Now let's talk about another theorem. This theorem says if two segments from the same exterior point are tangent to a circle, then they are congruent. So notice you have both of these segments, AB and CB, are both coming from point B, outside of circle D. Since these are both tangent to the circle, they only touch the circle at one single point, we can conclude that segment AB and segment BC are congruent. Let's use this in an example. It says the segments shown are tangent to the circle, find the value of x. Since they're tangent to the circle and they're both coming from point B, we know that they're congruent. So I can set their measures equal. X plus 15 must be equal to 2x minus 5. Add 5 on both sides, subtract x on both sides, and you'll get the value of x is 20. Go ahead and try to find the value of x on the example to the right. Here's the correct answer. And finally, I want you to reflect on this question. In the figure shown, xy and xz, these two, are tangent to circle A. xz and xw are tangent to circle B. Explain in 1 to 2 sentences how you know segments xy, xz, and xw can all be congruent if the circles have 2 different radii. That's all I have for you today. Remember, tomorrow we will use these properties of tangents to talk about circumscribed polygons. Talk to you then.